Deep,
Hi.
how are you, man?
Good, how are you?
Great. So I'm really looking forward to this.
Cool.
What's going on today?
Me too. We have another very special guest with us, Alex. Hi, Alex. Caught you in the middle of a sip of water.
How's it going, Deep?
How are you?
Doing good. I'm
See what he did there? He said, how's it going deep? It's going deep very well with you today.
Oh, yeah.
What are we going to talk about?
We're going to talk about the cluster manager.
Okay.
And I hear you have some questions to start off with.
I do, but before we get into that, we'd love
Sure.
to hear a little bit about you and
Okay.
sort of what you worked on the team, what you work on, because you've been around for quite a while in Service Fabric.
Yeah.
So we'd love to get to know you a little bit.
Okay.
Yeah, so please tell us about yourself.
I worked on the Service Fabric project back when it started, and it started off as a kind of, before it was called Service Fabric. If you
Right.
look in the code base, there are a lot of components. You'll see Windows Fabric everywhere. So I was working on it at that time when it was still called Windows Fabric before the name changed.
Right.
And so a lot of different components. A lot of system services are built on an underlying replicated store. That's a precursor to the reliable dictionary stack that I think you've talked about in a previous episode. Yeah. So it's a precursor to that. It's built on a database called the Extensible Storage Engine, and that's something that's available on like all Windows machines. And so that's a database that comes installed there, and so it's built on top of that. And so that's a lot of the stateful services. All the stateful system services are built on top of that.
So you've been working, is that what you started out with working on? Okay, and then you've also moved around to different components too, right? You've sort of been involved with a bunch of different things, and one of them is the cluster manager, which is sort of what we're here to talk about today. So I want to kick this off sort of from the perspective of questions that we tend to get a lot, and one of the ones we hear, or scenarios that we hear a lot about, is application upgrades. So let's talk about the CM, and if you could paint the picture for what it is, but perhaps in the context of application upgrades.
Sure. I guess it's not a very well-known fact that you can actually run a cluster without the CM enabled. So early versions of Service Fabric, you can actually disable the CM, and it's like it never existed. So you had the concept of services without any kind of management around them. And so there were services, you had a failover manager and a naming service running, and that was enough to get a service running. What it meant, though, was that the operator of a cluster would have to kind of install and run their services, the execute with the hosted components by themselves. So they would have to go to the machines, start the exe, and then in the startup code, like in the main or whatever of the code, it would register the service types, and then if it ever crashed, you would depend on like the Windows services subsystem to restart that service.
I see.
Right? And so there's no such thing as an application manifest or a service manifest or any kind of packaging around it.
Yeah.
And so when we added the concept of an application, that's where all the stuff that you publicly use, the application manifest, service manifest, and then the cluster manager is what you go through in order to manage those packages and to enable the concept of applications. So the concept of applications don't even exist in the other system services.
Cool. And upgrades to applications are also orchestrated via the CM, right?
Yep. So both cluster upgrades and application upgrades are orchestrated through the CM. The base logic is shared between the two of them. So a lot of the base logic is very similar. And so if you look at the source code, actually, you'll see the way the CM is structured is that it takes on a request, persists the fact that request has been accepted after some validation. After it's valid, it runs the actual workflows in a background state machine. And so all these classes will be called something like a process, something, context, async operation. And so all those classes are the background state machine that runs.
Okay.
And so the upgrades, you'll see a process application context async operation for the application upgrades state machine, and there will be a process fabric upgrade context async operation, and that's for the cluster. And you'll see that they both derive from a common base class called just process upgrade context async operation. So the common upgrade code, stuff that's similar, like moving through the UDs, the fact that you have health checks, the fact that you have 3 different modes, like the way it rolls back. So that common logic is in the base class.
So we'd love to hear, I guess, then a little bit of what the CM actually is, and then how it interacts with some of the other system services.
Okay.
Yeah.
So what do you mean by what it actually is?
So what, like, good question.
So it's a stateful persistent service.
Okay.
Much like failover manager and naming is. They are built on top of the same underlying storage stack that I was talking about earlier. And so there's not actually a switch where you can switch between the old legacy, the original ESE-based stack, and kind of the newer, reliable collections-based stack. But the abstraction of the underlying component for replicated persistent storage is shared by all three system services.
And for the folks that are listening in, there is a video out where we sat down with Mansoor and talked about the FM, but we haven't really talked about naming. Could you give us like a very short intro to what that is?
Okay, sure.
And feel free to use a whiteboard or anything.
Yeah, so if you think about failover manager as being the unit of management that thinks about is the failover unit, right? So it's just a partition is identified by GUID as a partition ID, and that's kind of it. There's the namespace that you have on top of where you have a hierarchical namespace where you have like a name and a service, and the fact that you have different partitioning schemes, such as you have named partitions, you can have uniform partitions. The partitioning scheme and the naming scheme is what's built on, it layers on top of what failover manager is doing, and that's managed by the naming service.
I see. That's interesting. I didn't actually know that. So what's the difference between the two kinds of partitioning schemes that you just mentioned?
Okay, so the default and what probably everyone is familiar with is the uniform int, which is you have a big integer range, it's chopped up into kind of uniformly or equal sized partition chunks, and then however many pieces you've divided in, that's the number of your partitions you get, and each partition is associated to a certain key range. There is another partitioning scheme called the name partitioning scheme, where every partition is assigned just a string, so you have a list of strings, and each partition is associated with a string, and so it's not an integer range. And so instead of hashing your request to some integer, you would hash it by name. So one use case would be, let's say, if you were to hash by usernames, you could take your username and just directly use the username, for example.
So you have the different types of partitioning.
Yeah.
Why? Like, when would I use one versus the other?
So mainly it's right now it's mainly just a convenience, so you don't have to hash it to a key. You can use it directly as a string in your partition. So if there's something about your application where the scheme naturally maps to a string anyway, and the partitioning space naturally maps to a string, then you can use the name partitioning scheme. Fairly recently, we actually have a new feature where if you're using named partitions, you can actually extend the partitioning range. So with keys right now, it's fixed and you can't kind of change the number of partitions in your service. But with named partitions, you can actually add names on the end of it, like you can add, like you would add buckets to the end of a list. So if you had started with partitions A, B, and C, you could dynamically add and remove a new partition D, a new partition E, remove A if you want, and so your naming, your partitioning for your service can be changed dynamically.
Awesome.
Interesting.
Very interesting.
Yeah. So I'm going to switch gears a little bit and go back to talking about the CM.
Sure.
So what are like the relation, firstly, the CM is not, like, it does a few different things. So we've talked about how it helps orchestrate upgrades, whether they're cluster or app upgrades. What else does it do?
So, I mean, that's the biggest thing that it does. It does serve as an entry point for a lot of the queries because it's co-located with the HM. So a lot of queries are served through the CM. The HM and the CM actually share a physical database store right now.
Okay.
They're architected in such a way, like if you were to look at the code, you would see health managers in a separate directory. And it's written in a way that it can be split out to a separate service, but they're currently co-located for performance reasons for the upgrade, and they share the same physical database. But architecturally, it could be, if like it ever became a situation where the HM was a hotspot, we could pull out that component into a separate service if needed. And the protocol is designed so that there's a very low messaging overhead communication between CM and HM.
And you're saying the performance reasons because the CM constantly needs to keep track of health state for
Yeah,
entities.
during the upgrade, right.
Right, that's
so
how
it can
you
be,
roll
so there's
that.
a protocol between HM and CM to where pinging the health, and when they're co-looking at the same database, it just becomes just an API call between CM and HM, and they just read from the same database.
And in a similar vein, then, what are some of like the contracts or relationships the CM has with the FM or other components inside Service Fabric?
So with FM and naming, so it will mainly be all the service operations. So it'll be creating, deleting, and updating the services. So when you have an application with default services, for example, the CM during the upgrade will take care of creating these default services.
And does it have any other sort of contact with other parts of the core system services at all, or is that it basically? That's sort of the web of the CM per se.
That's mostly it. The hosting component also will contact the CM because the CM manages its applications. So the hosting component on each node, in order to perform periodic cleanup of application state after you've deleted an application, will contact the CM to figure out what applications are still alive and what kind of cleanup needs to happen.
Cool.
Yeah.
So
But
what about?
we've kind of designed it so it's not like really intermingled. So there's a fairly good hierarchy where it's like CM built on top of other components.
Amen.
So the CM to naming to FM, not kind of like a web of services, because it becomes a lot more difficult.
Yeah,
And that's the way it's designed, so that, like I said, you can actually have FM naming in a cluster and that's it, and you still actually get functionality, and you can still layer CM on top of it to get further functionality.
And that kind of goes back to Gopal's video. For people who haven't watched that, he explains exactly why. I mean, this is a distributed systems platform. These components shouldn't know about certain things they don't need to know about. That's a bottleneck.
Right.
But I mean, going back to Deep's question, the failover manager has a global view on anything that's happening at any time for obvious reasons. And you're something that's just sort of on demand, right? So something's going to say, cluster manager, do this, sort of like RA.
Yeah.
RA is told to do things by FM. And something's telling you to do things. What is that thing?
So it is to create services, create applications, upgrade those applications.
What about cluster upgrades?
And cluster upgrades as well.
Yeah.
Although, no, that's mainly for on-premises clusters. If you're going through SFRP, you typically do not do that. You would go through the portal, like as an end user, you wouldn't see it. You go through a portal and you just kind of like click on a drop down that says, oh, I want to be at this version. But then underneath the hood, that triggers an upgrade of the cluster.
Right, but then what happens on-prem?
On premises?
Yeah.
Well, on premises, you do have the option to upgrade the cluster in exactly the same you would upgrade an application. And there's parallel APIs for cluster upgrade.
And we have basically the upgrade orchestration service that sort of does that and layers on top of the CM.
Yep. It exposes like a slightly different model. It uses like JSON configuration files.
Yeah.
But it also just calls these same APIs to the CM that you could call directly if you wanted to.
So source prod, source management.
Cluster manager?
What's up?
Yeah, we're in a new subsystem.
Get in there, man. And then we're in the management one, which spans them all.
Yeah.
Right? Because they all are going to order it around.
Well, what do we have? We've got
Communicate with
hosting, we've got CM,
Yep.
we've got naming service.
Yep. So now it's whiteboard 30. And so we can crack in, like going back to Deep's question, what is CM? Let's crack it open. Like, what's inside of CM? How does it work? Why did you design it the way that you did?
Sure. Let me think. So the way, if you were to look at the code, there are kind of three main layers in the CM code base. There's what I'm going to call like the client proxy side. There's the replica itself, so I'm going to call this the CM replica. And then there's something I'll call this like the background state machine. And kind of everything conceptually maps to a bunch of classes. And so conceptually, the flow that happens is a client request, after going through the gateway, it's going to enter the client proxy, which determines what kind of request it is, and forward that to the actual replica itself. So this is the core replica code that's built on top of the
Replicator.
the replicated persistent state machine.
Right.
This guy will do some initial validations, determine whether or not the request is valid. If anything it gets invalidated, that the request is rejected, goes back to client. If it's accepted, it persists local state. It says this request has been accepted and now it's ready for processing. And there is a background state machine called the rollout manager, and this is a actual project. So there's a rollout manager that then picks up the accepted requests
Okay.
and then runs them in these background async operations. And so the process upgrade async operation is one of those things that it does in the background.
And how do we prioritize or manage like a lot of incoming requests that are
So
being accepted?
yeah, there is some throttling on certain requests, but that's basically it.
So what I mean,
there's
like,
no
if
there's
I
no
try to-
priority between certain, because there's not anything that conflicts is going to be on a per application basis. That's kind of like the unit of managing
Correct,
the application. So if you try to do delete and create of the same application, we will take care of the logic that makes sure the right things happen. You can't delete an application that's already created and so on.
So what happens in the case that I like do a delete and a create at the same time by accident? Would I be rejected at the first stage itself? Or?
Yeah, they'll be in the first stage. So that's part of the initial validation. So delete application will look up what kind of persistent state exists on the application name, and then if it's not there, it'll get rejected with the data wasn't found. So everything, well, not everything, but a lot of the keys that have to do with the application are keyed by application name, and so it uses the underlying key value store as kind of the mechanism for conflict resolution, and that kind of just maps naturally to a lot of the operations
So
because they're based on a per application or per service basis.
Is there like some kind of dependency here on basically time then, which is when an incoming request is accepted?
If just a user is literally kind of executing them in parallel, then yeah, it's going to be which request reaches the server first.
Okay, and what happens to if there's issues with the incoming requests, and how do we handle persistence in incoming requests if the CM replicas themselves are also experiencing failover at the same time? Because it's kind of like the same way user data is now handled in a stateful service, right?
Yeah, so if I get what you're saying, well, so once the request has been persisted, and it can be replied that it was accepted, then on failover, because it's persisted, it can load up everything, and it knows the state that it left off at.
Yeah.
So it will rehydrate and continue the context from that stuff. And then all the data derives from a base class that keeps track of like the fundamental states, and so. In the rollout manager, it uses a base class called the rollout context. And so I'll write that down here. The rollout context, which is the base class for all the contextual states. So every request that comes in is going to derive from the rollout context. So a request to create an application, there's going to be an application context that derives from rollout context that keeps track of all the persistent state that's needed to continue processing requests should the CM fail over for whatever reason.
Right on.
And if you look at the code to dive deeper, this derives from another class called this store data, which is a base class that contains some very basic data about the actual unit of persistence in the replicated database as well.
So follow around, folks. We gave you the location. Like seriously, look at the code and understand it.
So I've a scenario I want to walk through. So suppose we come to the client proxy, we decide we want to deploy an app, we also want to do a cluster upgrade, and then we ask for an app upgrade for another app that's running the cluster. So we have these three things. They won't actually be accepted back until not only is it in this particular replica, but at least a write set, because that's by virtue of this being a stateful service. That way, even if CM fails over that point, we still know that those tasks exist. What is the relationship now between having a list of tasks in this key value pair here and the rollout manager deciding to start initiating on one of them? Is it instantaneous at the moment something comes into this dictionary, I'm going to pick this up? Yeah,
so there is logic here. When it processes each request, there will be an in queue into the rollout manager's in-memory queue. So it's persisted, it's there. If this rollout context is persisted in the state, so it's there, it's replicated. Once it's replicated, and we know that it's persisted, it will also in queue into the in-memory processing queue inside there, and that's all inside the rollout manager class. And then that keeps a list of all the pending active contacts to be processed.
So the one question I have for you back in terms of the code, in the code base, I've noticed that there's sort of a group of people who use coroutines, and Deep will laugh because I always have to bring up coroutines, but and then there's a group of people who sort of use the old async operation that has these sort of really interesting type that basically can be anything that you pass to this template. Anyway, make a long story short, which one are you using? Are you using the old school or using the new school?
It depends on the component. So the newer components like the native store stack that you've talked about, because those are newer components, they are built from scratch, and so they are able to use the new coroutine. So a lot of these older components that have existed from a while before are using this async operation model.
Understood.
And so the cluster manager is using the async operation.
Does that add any strange overhead to debugging?
I think it depends on the person working at it. For me, it's okay. So like I did actually mention earlier, there's a switch in the store now between the two different types. So this is built on top of an abstracted layer called the key value store replica, and that's under source/store. And so this has the ability to switch between the two different types, the ESE based type and the I'll call it it's called T-store.
Yes, correct. And we had Preeta in here talking about that.
Okay, great, fantastic. So it switches between the two. So this exposes a common API that the system services like CM, failover manager, naming services, they'll all use underneath. And so because it's plugged into all these kind of older components, it does expose the older async operation model. And then so because the T-store uses the new coroutine models, this abstracts that out as well for it. And so this interface uses the old one, but you switch between the source and the coroutine. This stuff is implemented using coroutines, and this would not be.
So one of the biggest takeaways for me from this conversation has been like how interesting it is that you can actually have a cluster without the CM. Like a lot of the conversations I've had, people actually allude to the CM being an extremely core, or extremely important. I've heard jokingly like the CM is the most important like system service in Service Fabric. And on one hand, I understand, right, because it's orchestrating all the actual placement of applications and services and upgrades. But on the other hand, what you just said is you can effectively run a cluster.
What you miss is the management aspects of it. So without the CM, you don't get the concept of applications. You don't get any management. You don't get automatic deployment of bits, right? There's no way to.
So really, what do you get then? Because what is FM? If you just have FM and naming, you're not even getting like true replication. You said, right?
You get replication. You get replication. You get failover. So you get high availability and you get fault tolerance.
So how do you get high availability if nobody's deploying enough like instances of the?
That's true. Yeah. So you would have to pre-deploy. So you would have to, because you don't have the management access. You don't have the automatic deployment access.
So you're effectively teaching
you have to
FM.
Pre-deploy it. Yeah. And then FM can detect the failures and can fail over for you, but you don't get.
So you're basically telling the FM, by the way, I've got 3 replicas. They're on machines 1, 2, and 3, and now you help me keep them in the same state, and you help me fail over
Well, that's one way to do it. I mean, if you were using that older model, I'm not encouraging anyone to do
that. I'm just curious now.
Sure.
But if you were to deploy it that way, what you would do is actually run similar to what like a stateless service runs like today, a -1 stateless service. You would have the host process running on every node so that you have the possibility of placement for every node, and then it would work very similar to this. You still don't get an automatic placement. You don't get that having automatic, but you would want to set up your cluster so that you have that host process automatically run.
So the questions then become, why, so beyond just perhaps backwards compatibility, why would someone not want to run the cluster manager? So for example, maybe I'm doing my own on-premise thing. I don't want to use your cluster manager. Maybe we want to write our own. I don't know if anyone's actually doing that. Like maybe SQL, like some of our customers inside, maybe they want the option to not have to.
But imagine
that's what I'm asking you. Like, so why would I not want to have a cluster manager versus the fact that it can work and I have a bunch of overhead? What are some of the like realistic engineering reasons why that might actually be a good idea for some context?
I mean, if there was no reason for you to need our manager, then you could could run it without. I
Okay.
mean, our goal is to make it so that the management is so useful
Yes.
that you wouldn't want to turn
Right.
it on.
I mean, can you imagine not having applications as a concept?
No.
That'd be ridiculous.
But so,
Like, yeah,
but so what are you doing? Like, that's why I'm asking. Like, so what would you be doing if you don't have the concept of an application? Like, why would I use service?
Why would you use
drivers?
service hierarchy? Yeah, that would be my
Okay.
question. That would be my immediate question, actually. So,
But I'm glad that you have the levers and knobs that if we want
Yeah.
to, you can do it.
Yeah.
but I mean, what's interesting though about the CM2 then is since you sort of, as you talked about it a little bit, you gave us a mini history of the CM where it sort of came afterwards. We realized that we need to handle these abstract types and handle applications. So that means you got to architect this a little bit after some of the other pieces were already architected and existed. So you probably got to go about it in a more intelligent way because you were aware of some of the dependencies that needs to. So along that vein, if you can think back to the time where you guys were like designing the CM and writing it, what were some of the key challenges that you had to think about? What were some of the different approaches you considered, and why did it end up being designed the way that it is now?
I think some of the main things that came out of it were kind of more on the store level, where some of these classes that I'm talking about, like the store data class, that makes it easier to manage the actual persistent state. Some of that came out later, and so if you look at the failover manager or the naming service, it's actually not using these new classes, whereas the health manager and CMR.
Interesting.
And then the request model, processing model is slightly different in the naming service than it is in the CM. The naming service doesn't have this kind of background processing decoupling that the CM does.
So it actually handles these requests and returns.
Yeah, it's kind of like,
Okay. And then for those of our users that are used to dealing with clusters in Azure, we have this concept of durability level that we talk about, which effectively is the amount of time that you get when Azure decides something has to be upgraded about your machines to basically do whatever graceful shutdown you need and whatever service traffic thinks it needs to do for your services to continue running before it can do like a patch to your operating system or modify the status of your VMs. What is the relationship then between the Azure components that are underneath at the VM scale set level, and do they communicate directly with the CM as well, or is that something that's abstracted and treated like any other client request?
So there's a bit of history here, so everything has a bit of history. It used to plug into the CM. So in the CM, there's still some code there's code that's still there related to infrastructure tasks. So there's code called anything that has to do with infrastructure in the name is what was hooked up to the durability levels. And so Azure would call, there's a protocol between CM and Azure to figure out when it was safe to proceed with an upgrade and so on. That logic has since been split out to a different service now, but it's also under management.
So that's the infrastructure service, I believe, right?
Yeah,
Or something like that, yeah. So does that then have to work with the CM at all, or is that runs everything abstracted away from the CM?
That runs everything away from the CM.
Okay.
I was actually talking about the repair service.
Oh, the repair service.
Yeah, so the infrastructure service and the CM were together. They were working together along with Azure, but they were actually part of the original model.
I see.
This was actually been split out.
Interesting. So the repair service does what? Like resume state?
Yeah.
Okay. Make sure it
I mean,
passes it back to
the
right thing.
stuff that CM and infrastructure service used to has been split out to the repair service.
Cool. Make them more lightweight. Decrease the amount of code in the repo for you under that folder.
That's
Sweet.
a giant repo.
It is. It's a huge repo, but this is really helpful. I love bringing the code right to the conversation.
Yeah, it is.
We said we were going to do a lap around the code,
Yeah.
and that's what we're doing.
This is an actual. Yeah.
We're starting.
What do you think what do you think was the biggest challenge in sort of designing the CM? Because you have unique insight into this. I mean, compared to anybody else on the team, really.
Sure. I think probably just maybe mapping the state machine for the upgrades. That's I think the most complicated state machine, and it was also something that grew organically as features were added to it, and
Yeah, cluster upgrades as well as app upgrades tend to be.
It started off as a simpler model, but then kind of grew from there.
What do you mean? What was it initially? Why was it simpler before? I mean, because we only think
the
of it
modes
moving
were
on.
all added, like health. The most common upgrade that we want people to use, the monitor, didn't even exist originally, so it was always manual. Like only unmonitored manual existed.
Okay.
And so
So unmonitored
the idea was that we would kind of defer all the health check and stuff that happens automatically now to the user, and so you would have a UD complete, and then the client or the user decides, okay, well, is it good or not, and then I decide whether or not to move it on. But of course, it's way easier just to have the system pull in all that telemetry, do processing on it according to the policy, and then automatically decide whether it should move on or roll back.
Awesome. Agreed.
Yeah. And I mean, that means the HM came even after then, after the CM, basically.
Well, so it came kind of in parallel, but not with the upgrade mode didn't happen at the same time. It was, you could query for it, but the logic wasn't there to hook them up so that there was automatic
So today, if somebody queries HM for the status of an entity, is that coming to the CM as well?
Yeah, someone does. Well, because they are because they are deployed as the same. There's only one service. Like if you were to look on the dashboard in a cluster, like look through the portal and list the system services, you would see the cluster manager services, but you won't see an equivalent health manager service. Yeah. Right? And that's because the code is co-located. It's all running inside the cluster manager service. They're sharing the same database.
Right.
Does that mean they're running as the same service, and so the requests are going through the cluster manager, and then being fed into the HM. Okay. So if you look at the class that's cluster manager replica, so that's the main.
Right.
Replica. So cluster manager replica, there's code there when it opens to open the health manager replica as as a subcomponent. And so on open change role close, one of the things it does is feed that event to the health manager as a subcomponent.
Interesting.
Absolutely.
Yeah.
And so just to kind of maybe jump into areas that aren't that interesting, but so you're using the K-shared pointer. So are you using the KTL stuff for all your pointer?
Not in this code base. It would be in this layer and below. It would be.
Only, okay. Yeah. So but you're not managing memory.
No, this is just using the regular STL shared pointer.
Got it. Cool. Unique pointer, shared pointer.
Yeah, exactly. Just STL.
Make sure. It's really like if you go look at this code base, there's some nice modern goodness in there. I mean, C++ 11y. There's also some oldie kind of stuff, but it's pretty impressive and clean. So nice work. No, really. I mean, you can read the code.
Yeah, I mean,
that's always nice.
This has been really interesting for me. At least I learned a lot. But I have to ask you one last question.
Okay.
So we have heard that you're a biker.
Okay.
Is this accurate?
Which kind of biking are you talking about?
What kind of biking are you?
That's a trick question because I do both kinds of
kinds.
So
Exactly.
if you're talking about bicycling, I mountain bike.
Okay.
And if you're talking about motorcycling, I do have a motorcycle.
Interesting. So can you tell me what is the relationship between motorcycling and service fabric?
Motorcycling and service fabric. I don't know if there is a relationship there. You know who else has a motorcycle?
Who else is
Navy.
Navy is a motorcycle.
No way.
Navy is a biker. Yeah.
Navy's a biker?
Yeah.
We're gonna have to ask
He has multiple bikes. He has more bikes than that. I only have one. Navy has multiple bikes.
You gotta come up with something. We can't let you go until you come up with something. I don't care if it's like the spokes in the wheel and the wheel being a circle or a ring. You gotta.
A buffer?
That's just
no, you're not allowed to use that one now.
the ring, yes. The spokes on the hub.
Yeah.
Well, I mean, I guess one thing is, I love working on my bike, right? Like recently I just changed the front brakes and now it runs great. And I love working on code and I love working on my bike. I mean,
so there is a relationship between being a mechanic and writing code.
I think so.
For sure.
I think when you like building things,
yeah,
like you like building software, it kind of naturally spans into building physical things as well.
Yeah.
I mean, it's just fun to build things.
Yeah.
So I mean, one of the things like coming into this code base from like completely not in the distributed systems platform world, you can be overwhelmed sort of by the complexity. And so when you're writing code like this, like you've been doing it now for what, 10 years on the team, for a long time, like how do you approach like when you're going to add a new feature to something that's running inside of a distributed system that's going to have some dependencies? It's not 100% decoupled from everything else.
Absolutely.
So how do you approach it? Like I'm assuming you do a bunch of thinking before you start coding.
There is, yeah. I don't know if I can really describe the process that goes into it. I mean, it's the same. If you think of a distributed system actually as just like a bunch of modules, like what would you do if you were writing, even if you're writing a single system, you would want your modules to be loosely coupled. You think about the coupling. You think about when you call into one module or another, what kind of side effects is this module going to introduce, right? You think about if I were to draw a dependency graph and the way my functions are called, or if I were to split them up into directories, is it going to look like arrows everywhere, or is it going to be a nice clean hierarchy? And so a lot of those same concepts when we're building a single system actually map to a distributed system as well.
Cool. Thank you so much for your time, Alex.
Awesome.
Really appreciate it.
No problem.
Really do. Cheers.